Today, I'm going to share with you a controversial idea. Actually, we seem to have been taken lately by the financial crisis, the downturn of the global economy, as well as unemployment, amongst other things, to have forgotten about how to protect industries that, like agriculture, like energy, like infrastructure, all but cornerstone to our way of life, to our civilizations. Protecting them against changes, and not only to climate, but to bigger than climate, Earth changes actually. What I'm going to share with you could change your understanding of the past, but could also give you a different perspective about the future. We think that climate change is going to be severe in 100 years or 150. What if it is only in very few years, 3, 4, 5 years, in our lifetime? Can we take it? So allow me to start by addressing climate. And the first part of the climate, you might be surprised. It's earthquakes. You may think, what does earthquakes have to do with climate? Hang on with me. This is an observation. In the past 150 years, the number of earthquakes above 6.99 Richter have increased 14 times. The total magnitude of earthquakes in the last 30 years have increased 6 times. The number of earthquakes above 6 Richter, only in the last 10 years, have increased tenfold. So you may wonder, what is the cause of such alarming increase of earthquakes? This is an archaic pattern, how the magnetic pole has been moving. We may think that the magnetic pole and the rotation, geographical pole, they coincide. They don't. The axis of rotation is fixed, but the magnetic pole is keeping wandering. And this is for the past 3 millennia. It has been wandering all over the place. So could there be consequences to such moving of the magnetic pole? When we look to Earth, Earth actually is tilted. And there is a 23-degree shift between the axis of rotation and the angle about the solar system, the solar plateau. But strange enough, if you look into the magnetic axis that connects the two magnetic poles, it makes an angle gap of 11 degrees. But more importantly, if you look where the ice cap is located exactly along the magnetic axis, not along the rotation axis. So is there a relation between the ice cap and the magnetic field? Well, there is. If you look on the left-hand side, the magnetic pole has been moving from Canada towards Siberia. And in fact, in the last 10 years, it had moved the distance, the same distance it moved in the last century. And at the same time, if you look at the right-hand side, the comparison between 79 and 2003, you'll find that the ice cap is eroding from all sides except one side, the side that is closest to Siberia. And the red circle shows you that the ice cap is building towards Siberia and eroding towards the rest. So it seems that, yes, there is a relation between the ice cap and between the magnetic pole. It seems that the temperature is lowest where the magnetic pole is located. So what do I mean by temperature? In the mid of the last century, a Russian scientist, Vladimir Putin, has come up with this definition of temperature belts of homogeneous climates. We might have all seen this one. And you may think, why is the temperature very hot at the tropical belt, and why is it very cold at the polar pole? And people think because, the tropical belt is very close to the sun, and the angle of projection is right angled. But let's not forget that Earth is tilted. So you may ask the question again, why the tropical belt, the magnetic equator, is hottest, although on December 21st in this photo, for instance, it is not closest to the sun. In the dry climate belt is the closest to the sun. And in fact, the angle of projection of the tropical belt and the middle latitude belt are the same. The magnetic field that surrounds the planet protects it from electrons, from protons that are emitted by the sun. The sun, of course, emits infrared, ultraviolet, radio wave, other radiations. But what happens is the magnetic field stops these charged particles, heavy particles. These particles arrive to the surface of the planet, or not to the surface, to the atmosphere, at a very high kinetic energy. They are coming at high speed. They cannot penetrate. What do? they start to move along the magnetic force lines. They start to move go and fro between the north magnetic and the south magnetic. And of course, as the speed is different, in the midpoint between the two magnetic poles, where the magnetic field is weakest, they move at a very high speed. Towards the magnetic poles, they slow down, they stop, they U-turn, and then they come back on that trip. Now, going and froing between the two magnetic poles in the thermosphere, which is a very thick layer of the atmosphere, they make accidents. They collide with nitrogen. They collide with oxygen. And this accident generates energy. And if you measure the temperature of the thermosphere, you'll find that it ranges from 500 degree plus to a 2,000 degree plus. So the question becomes, which feel hotter? The sun, with a surface temperature of 6,000 degrees, that can go up to 2 million, but it's 150 million kilometers away, or the thermosphere above our head. It's only 100 kilometers, and it ranges 2,000 degrees to 500 degrees. And you find out that the difference between the energy reaching us from the thermosphere is 1,500 times the energy coming directly from the sun. So when you go out and you walk, the heat that you feel, it's a hot day, it's not coming directly from the sun, it's coming from the thermosphere, thanks to the interaction of the magnetic field and the protons. Then if you think of it, if the umbrella above our head ranges from 500 to 2,000 degrees, and it gives us the heat, could it give us also the temperature belt that we spoke about earlier? Yes, it will give us. Where it is 2,000, gives you the tropical heat. Where it is 500, give you the polar belt. So the climate on the surface of the planet follows directly the temperature map of the thermosphere 100 kilometers above our head. Now, what happened when the magnetic field gets weaker? And in fact, it has weakened 10% in the past 150 years. And this weakening is accelerating. It has weakened, and a 5% only in the last 30 years. So the weaker the magnetic field, the happier protons are, and they will travel faster. And if they travel faster and they collide at a higher speed, they generate higher energy. And this is why we have global warming, ladies and gentlemen. So global warming, simply the magnetic field force has weakened. The protons are going forward and backward between the two magnetic poles. They collide at a higher speed and generate higher energy. But we also have a climate, I would call it exchange, not change. Why? Because the temperature belt that I spoke about earlier are tilting along. If the magnetic pole is moving from Canada towards Siberia, and this is happening, the whole of the temperature belt is tilting along. So regions or countries like North America are getting warmer, and regions or countries like Middle East are getting cooler. So this is, ladies and gentlemen, the reason of global warming and climate change. Has it been done before? Over 1,000 years ago, the University of Extremadura in Spain have found ancient texts done by the Arabs over 1,000 years ago. They speak of bitter cold in the Levant countries, Syria, Saudi, northern Saudi, Iraq. And at that point in time, you will see that the distance of Arabia to the magnetic pole then in Siberia is the same distance as Europe to the magnetic pole in Canada. So Arabia at that point in time enjoyed a climate very much like what Europe is enjoying today. And this is a proof also that the temperature belt is moving along with the magnetic pole. Now, one more thing, that the two magnetic poles are in isolation of each other. They move freely. And in the last century, the two magnetic poles have distanced from one another like 1,900 kilometers. And this had led to a weaker magnetic field in the middle, as the magnetic field has to travel longer distance. And this has caused what is called the South Atlantic anomaly, which is an area of very weak magnetic field and overheated temperature. Where is these magnets coming from? I spoke earlier a story of 3 magnets. If we look, we all know that Earth is bulged. Why? Because it spins quickly about its axis. So the equatorial part of it trying to run through space, and the gravity is pulling it. So it is bulged. But this bulge is also repeated in the inner layers inside the planet. And it depends on the radius, and it depends on the thickness of the material. And by simple math, we find that the outer core, which is a viscous liquid, is 3 much bulged as the crust. And you will find out that this helps to keep the planet spinning about its axis, as I will show you. Now, the inner core, scientists, they tell it's an isotope, so it keeps emitting free electrons. These free electrons swim, flow in the outer liquid, viscous outer core. But since Earth is spinning, such a move of electrons seems to be going in spiral. And of course, we know if we have a rotating electric current, we get magnetic field. So we end up by having 2 magnetic fields opposite each other, parallel to the axis of rotation, and fixed. But hang on a second. The magnetic pole is moving, as we saw before. So the magnetic field that we observe on the surface must be coming from a different source. It's not generated. It's not induced. In fact, in the heart of the planet, we have 3 magnets, 2 generated from the electric loops, and 1 is a permanent magnet. And this 1 permanent magnet is observed when you go to the Antarctic, you find the north magnetic pole. You go to the Arctic, you find the south magnetic pole. But then you find pockets of small south magnetic poles on both ends of the planets, on both caps of the planets. And this is simply, as I explained earlier, the 2 induced, 2 generated will appear as small pockets of south magnets, but there is 1 strong permanent magnet. And then scientists think the magnetic field might be reversing in the Antarctic. It's not reversing. These small south magnets, or we call them plasmoids, have existed only 10,500 years ago, which means Earth was not spinning as fast then. Because had it been spinning, you would have had electronics moving in circles and induced magnetic fields. But since we don't have them before 10,500 years ago, it means Earth was spinning slow. So how does this bulge outer core in which electrons flow help the planet to spin? Very simple. If you have electric current and you have magnetic field, you get force, the left-hand rule or Lorentz force. So this force exercising along the perimeter of the outer core and the inner mantle helps the planet to spin. Now, what happens when the angle between the magnetic and the electric current gets smaller and smaller? If it gets smaller, the force will be less. So the planet will spin slower, and the day will be longer than 24 hours. If the angle reaches 0, there will be no force, and the planet will stop from spinning. You may wonder, has it been observed before? I'm coming to that. Some people are smiling. That's good. If the angle goes on a negative trend, then the force will be on the opposite side, and the sun will arise from the west. Very simple. Now, has it been done before? History. Where do I find history? On ancient temples, as well as in holy books, Old Testament, New Testament, Quran. These include history chapters. In the Old Testament, Earth stopped twice at the exodus of the Israelites from Egypt, where the night lasted longer than 3 days. And later, when Joshua was fighting in Palestine, the sun and the moon stopped. Actually, Earth stopped, as the angle between the magnetic and the current reached 0. But what made it so? What made a magnet to tilt? It's another magnet. It's another planet. It takes a magnet to tilt a magnet. Well, this planet, has it been observed? Yes. Again, it has been observed at the night where Egypt entered into 3 nights long, as well as it has been observed by Abraham. Now, the difference between Moses and Abraham is 5,000 years. The difference between Moses and us is 3,500 years. So there seems to be a cycle of repetition. Every 3,500 years, there are changes happening above our head that is causing our magnet to tilt and accordingly Earth to enter into this dilemma. But let's go back from history and find out if the angle between the magnetic field force and the current is changed. Does it impact the number of days within the solar year? Yes. Now a solar year has 365 days. In the previous cycle, 160 days. In the previous cycle, 96 days. And this has an impact on the aging process of the human species. Human species age by the succession of day and night. They don't age by the number of solar years, thanks to the pineal gland. So, where is this planet that has a magnet that tilts our magnets coming from? If it comes every 3,500 years, and then when it comes twice in 50 years, it means it has an elliptic path. And actually, NASA is trying to find out. They have sent their wide infrared space explorer to trying to figure and to image the Oort cloud and find out about this planet. As it approaches, first thing it does, it pulls some of the magnetic field force lines, and this causes losses of these lines. That's why when you are in Paris or Rome, looking at the sky, measuring the magnetic field, you think it's weakening. It's not. Because at the source, at the north magnetic down there, it's 100% strength. It's only lost a couple of magnetic force line with the other magnet. And that causes, as discussed earlier, weakening of the field, protons traveling faster, hitting oxygen and nitrogen, and generating more heat, and causing global warming. But more than that, if you look into how to verify that the north magnetic at the south has not weakened, simple. While at the Arctic, the ice cap is melting, at the Antarctic, the ice cap is growing. Why? Because the magnetic field is untouched, is as strong as ever at the source. So, also, when this planet approaches, when its magnets approaches, it pulls our magnets. So that explains why the magnetic pole is moving from Canada towards Siberia. So put one and one together. Global warming, gentlemen, ladies, is not caused because of CO2 or any man-made interference. CO2, by the way, is good for plants. And as I mentioned, the temperature belt will tilt along with the magnetic pole. The action that I'm suggesting is, first of all, let's define when exactly. I had looked into the Mayan. The Mayan were not prophesizing. They were using astronomy to determine the cycle. And actually, the scientists who deciphered the Mayan back in 1927 had made a mistake. They assumed, because the Mayan has used number of years to explain their cycle, the scientists assumed that the solar year is 365 days. But that's true in this short cycle, 3,500 years. But what about the one before? It was 160, but they didn't know that. Applying the right number of days per year, it ends up that the Mayan cycle is a 7,000 years, is not a 5,100 year. Two, nothing will happen in December 2012. In fact, if they're right about their astronomical equation, it will be 2017. So what if the magnetic pole keep moving until it ends up in India? We'll have an ice cap in India, and it happened before. We had it even in Australia before. The day is longer, the temperature belts will tilt along, the whole meteorological and precipitation map will tilt, as well as the aging process of the humans will grow much, much slower. Lower seas between the tropics, higher seas anywhere else. Then what do? We have many, many industries I spoke about. Agriculture, energy, infrastructure. Some land will become fertile, some will become arid. And in my recommendation, the United Nations is the best body to develop policies, policies of change. If countries are taking the lead, each country will take an industry to transform, to plan for the transformation. You know, we always say failing to plan is planning to fail. So if they plan for the transformation, when the time comes, they execute the plan. then we have a smooth transition. And finally, I put all this in a book I published on Amazon, but also on a website that you can go if you are interested in further details. I'm sorry if this has brought some distress to the audience, but it's not fiction, it's science. And I only integrated established sciences with a different view, hoping that scientists will go even deeper in each one vertical, one segment. Thank you very much, ladies and gentlemen.